Hello YouTube, in this video we're going to introduce the concept of a linear inequality, and we've been discussing linear equations for a while now. And of course when we talk about linear equations we're talking about anything that looks perhaps like this: ax plus by equals c, or y equals mx plus b, which of course are standard as well as slope-intercept forms of linear equations. So we say slope-intercept form. I'll fit this word slope in here. Slope-intercept form of linear equations. But in this video we're going to be discussing linear inequalities, where we're not dealing with something that says equals, but perhaps something that, if you can see over here, says maybe less than or equal to, or greater than or equal to. So let's go ahead and start with this. When we talk about linear equations, we are often considering a set of solutions to this thing. And when we talk about something that is a solution, we're saying it's something that when you plug it in would cause this to be, like a true statement. So for instance, if we were to say here, okay, well, what could I plug in for these 2 points to cause this to be true? Well, what if I were to plug in the point 0, 3, which is some xy pair that, if we were to sketch this thing, by the way, 0, 3, would be on the graph of this. We're not going to be graphing in this video, but I do want to point this out, that this solution would be on the graph. But basically, if we were to substitute this back into the original equation, it looks like we get this 3 times x plus 2 times y equals 6, where in substituting for x, we're putting in a 0, and substituting for y, we're putting in a 3. So we could see that 3 times 0, which would be 0, plus 2 times 3, which is 6, equals 6. We get 6 equals 6. So we are concerned with solutions to linear inequalities in this video and how they are related to, say, like an equation situation. Okay, we say that an ordered pair xy is a solution of a linear inequality if the inequality is true when the value of x and y are substituted into the inequality. So before we even move on, what I'm going to tell you is this: what if we were dealing with something that looked like this? Y is greater than or equal to 3x minus 9. Now I'm getting this from here, as in my example, but essentially this behaves the exact same way. We're saying if something is a solution, then it's true when we plug it in. It's just that I would challenge us to think, well, how many things could make this true? And when you think about it, when you say greater than or equal to, we could actually come up with many more pairs of solutions than we could for just an equation, because an equation has a certain set of solutions that is very, very distinct. But this would include not just the ones that were distinct, but any that were, say, greater than or equal to. So let's go ahead and just practice. How do you check to see if something's a solution of this? Well, we're just kind of practicing something we already know. We're saying, is negative 6, 2 a solution to this linear inequality? And so what we're going to do is we're just going to go substitute these in for x and y respectively. So it looks like we get here y is greater than or equal to 3 times x minus 9. Where we're substituting a negative 6 for x and a 2 for y, and we're saying, is this a solution? Does it make it true? So simplifying this, we get 2 is greater than or equal to, well, 3 times negative 6 is negative 18, and negative 18 take away 9 more is negative 27. So now the question is this: is 2 greater than or equal to negative 27? And the answer here is yes. Okay, so what this means is basically this is a solution of y is greater than or equal to 3x minus 9, because when we plug it in, it causes it to be true. So here's what we're going to do in this very last example here. It says example 1. All I want to do is check to see if these ordered pairs are solutions of this given particular linear inequality. Okay, and so we have 2x plus 3y is greater than or equal to 5. So in this first instance, we're saying, what if the point 0, 1 were plugged in? Would it cause it to be true? And so we see here that if I were to take 2 times x plus 3 times y and say it's greater than or equal to 5, and just substitute these values in, we say, well, 0 is going in for x and 1 is going in for y. Looks like we get 0 plus 3 is greater than or equal to 5, which simplifies to 3 is greater than or equal to 5. And the thing I want to point out here is this: not true, not valid, not true. So what this means is this is not a solution of this linear inequality. Okay, so that's important to be able to tell if something's a solution. Now let's check this guy here. We say 4, 1. Again, we're saying 2 times x plus 3 times y is greater than or equal to 5. But in this case, we're saying if I put in a 4 everywhere I see an x and a 1, negative 1 everywhere I see a y, and simplify this, I get 8 minus 3 is greater than or equal to 5. I get 5 is greater than or equal to 5. And so this is kind of an important deal here, but is this true? We actually say yes. Okay, and the reason why is because we did say that 5 is not greater than 5, but we did say it could be or equal to. So yes, 5 is greater than or equal to 5. Okay, and we're going to check this last one here. We say 2, 1. So we say 2 times x plus 3 times y is greater than or equal to 5. Would it be true if we were to plug in a 2 for my x and a 1 for my y. And so in this case I get, well, 4 plus 3 is greater than or equal to 5, and clearly I can see that 7 is greater than or equal to 5. But when we talk about linear inequalities, okay, so this is a solution. This was a solution here. Solution. And in the first one we had not a solution. But basically, a linear inequality behaves much in the same way a linear equation does, and we still check to see if things are solutions of a linear inequality by plugging it in to check to see if it's a valid statement. On my next video, we'll talk about how to graph a linear inequality.